Positioners, like the ones you see here, are devices that allow us to accurately throttle the control valve at a desired set point. Many styles are available depending on the type of control valve you have. All positioners require two things for proper operation: input and feedback. Input is the control signal that provides a set point. Feedback indicates the current valve position. Let's take a closer look at positioner operation in this animation. Input is provided by a pneumatic control signal to a bellows. As input is increased, the bellows will expand and act on a beam. The beam pivots and moves a flapper in relation to a nozzle. As the flapper position is changed, the nozzle pressure changes and operates a pneumatic relay. At this point, we simply have a pressure-to-pressure transducer for the input. To make it a positioner, we must have feedback. The feedback ensures that the control valve is responding to the input and that the valve position corresponds to the given input signal. In this animation, the feedback is provided from the control valve to the positioner by mechanical components. We're using a cam attached to an arm that rotates as the valve strokes. The feedback also acts on the beam and is an opposing force to the input signal in the bellows. If an increase in input is made to the device, the bellows will again act on the beam and move the flapper closer to the nozzle. As nozzle and output pressures increase, the valve moves and feedback from the cam acts on the opposite side of the beam, moving the flapper away from the nozzle. The beam is a summing component. The input and the feedback are both applied to the summing beam and are constantly compared to each other. If the forces are equal, the nozzle and the flapper relationship remains stable, and the output pressure from the device is constant. The valve position is then maintained. If a change to one of the forces should occur, the flapper is again adjusted in a relation to the nozzle, and output pressures change until both forces are once again equalized. If the positioner is properly calibrated, the valve position will correspond to a given control signal. For example, in this animation, a 3 to 15 psig control signal is used for the input. At 3 psig, our valve is fully open. At 9 psig, travel will be 50%. And at 15 psig, the valve is fully closed. The positioner gives the control valve the ability to overcome valve friction and process forces that may cause position deviations. Well, there are many additional benefits to using a control valve positioner, other than just stem position accuracy. Positioners are often selected to achieve throttling control of piston actuators, to accommodate non-compatible control signals, to ensure proper shutoff of the control valve, to enable split ranging, and to change the gain characteristic of the control valve. Thanks for watching, and I'll see you in the classroom.